missing out on Will's presentation.
As I already said, I kicked off Professor Rebecca Lazaridis out of this time slot just for Will. So, you know, all good. So thank you very much. And of course, it is traditional to acknowledge elders past and present as we do a walk through country. Today we come from Camaragal grounds, and we thank elders past and present for their continued custodianship of the lands and waterways in which we visit and pass through. And I'd just like to welcome everybody to this mid-candidature review of Williams. And I'd like to introduce this PhD panel consisting of Associate Professor Baljinder Sadra as Principal Supervisor, Professor Joseph Sirachi as Co-Supervisor, Dr. Maddie Fraser as Co-Supervisor, and Luke Downey as the Associate Supervisor End User. And on today's MCR Milestone panel, I'd like to welcome Professor Jessie Gale as the Expert Panel Member, Associate Professor Keon Yap as the other Expert Panel Member, led by Professor Teresa Dickey as the Chair. So without any further ado, can I ask people to mute themselves while we get William to present? The floor is yours. Thanks, William.
Thanks, Ricky. Now that you've mentioned, you've given me prime spot, I feel there's a lot of pressure to deliver, so hopefully it does. But yes, thanks everyone for coming. Obviously, my name's Will, and my PhD is titled What Works for Who? An Individualized Approach to Identifying Determinants of Wellbeing in Adolescence. So to start it off, I guess I'd wanted to give a quick refresher to anyone who, I guess, was at the COC, and to anyone new, sort of a bit of an idea on what my PhD is about. So unfortunately, at the moment, there's a bit of a global youth mental health crisis. And just as worryingly, what the research shows is the efficacy of the current standardized interventions for youth haven't really improved over the last 3 or 4 decades. The good news is, one solution that has been touted as a sort of, or one idea that has been touted as a possible solution to these issues is the personalization of these youth interventions. And so I guess my PhD is sort of asking the question, how can we sort of achieve this personalization? And the way I think we can is by using what I call a data-driven approach that sort of uses and analyzes intensive longitudinal data to identify what sort of processes of change or mechanisms of change are linked to well-being for an individual. And then theoretically, we can target these processes for that individual sort of in therapy. So my PhD is split into 3 studies. I'm hoping that the image is clear because it was before, but never mind. It's split into 3 studies. So the first study will be a meta-analysis and review that compares personalized interventions to standardized interventions in adolescents in terms of their efficacy. And that's sort of asking the question of, well, should we even personalize? Because I guess if there's no sort of benefit to doing it, then there's no reason for us to personalize. The second study is a simulation study that will compare different statistical and machine learning algorithms in their ability to identify what I would consider sort of reliable or important variables. And that study asks the question, I guess, of, okay, if we should personalize, how do we do that? And what sort of tools do we use to achieve that? Study 3 will then be a feasibility study that sort of looks at implementing this sort of data-driven approach to personalization into a real-world setting. And I guess that asks the question of, okay, well, if we should do it and sort of we know how, what tools to use, how do we actually implement something like this? And so, without further ado, let's move on to the first study, which, like I mentioned, was a scoping review and meta-analysis that looked at the efficacy of personalized psychological interventions in adolescents compared to current standardized interventions. And as you can see, this article has already been published last year. And you might notice there are some big, well-renowned names on this paper, like this one. No, I'm just kidding. I know that guy. He's a bit of a smartass. But in terms of the review, so we pre-registered it, or I pre-registered it on OSF, and we based the methods on a very similar review that looked at the efficacy of personalized interventions in adults by Nye et al., which was done just previous to this review in adolescents. And in the review for adults, they found an effect size of 0.23, which favored personalized interventions. So like I said, we used similar methods. We expanded the databases a little bit. So we looked at PsycInfo, Scopus, Web of Science, Medline, and Embase. And In terms of the databases, we found 1,263 articles for title and abstract screening. That was reduced down to 29 for full text screening, plus 7 from citation searching. And in the end, we ended up with 8 studies that were spread across 13 different articles. So in terms of the meta-analysis, we used a Bayesian multi-level meta-analysis. And we used a Bayesian meta-analysis because I felt there were a few advantages to that. One being that it's better for having a smaller number of studies, such as the one in this meta-analysis. And we could also use prior distributions or prior knowledge and assumptions, which can help the model. And we used priors that were based on the results that were found in the adult meta-analysis. I did a multi-level meta-analysis that nested effect sizes in articles and samples, because all the articles reported on more than one effect size. And like I mentioned before, some articles used the same sample or were part of the same study. In terms of the results of the meta-analysis, what we found was that there were 7 studies that reported on post-treatment effect sizes, and we found a pooled effect size of 0.21 that favored personalized interventions. There were also 4 studies that reported on follow-up effects, and we found a pooled effect size of 0.25, again, favoring personalized interventions compared to the current standardized interventions for follow-up. And these results are sort of very similar to what they found in adults, which, just to remind everyone, was 0.23. So based on the results of this meta-analysis and the adult one, I guess we can relatively safely say that there is a benefit to personalizing interventions for both adolescents and adults. And doing so does make the intervention slightly more efficacious than the current standardized interventions we use. Sorry, I forgot about that. What the review told us as well was that there was significant heterogeneity in sort of how the different studies achieved that personalization, how they approached it and actually personalized the intervention. And what was very interesting to me, at least, was that there was only one data-driven model or approach in the adolescent in my meta-analysis. And I found that surprising because, like I mentioned at the start, I think that's a very useful way to personalize because, like I said, if we can analyze intensive longitudinal data for each individual, we might be able to identify which processes are more strongly associated with outcomes of well-being for each individual, and therefore focus on those processes sort of in the intervention. And another benefit as well is simply data-driven algorithmic improvement. Now, one of the possible reasons I thought that there was only one study that used this sort of approach was maybe that because it's a relatively new area of research, there might not be sort of a standardized way to do this. And there are a lot of algorithms and tools out there that could be used. And I guess people might not be sure on, well, which one might be the most effective or the best one to use. And that's, well, hopefully what my second study, the simulation study, will try and find out and sort of resolve this issue. So the second study of my PhD is a simulation study with the goal to sort of determine and find out what algorithms or tools might be the best to use when it comes to analyzing that sort of intensive individual longitudinal data with the goal of sort of identifying which processes are linked to well-being for each individual. So my aim was to compare several statistical and machine learning algorithms in their ability to reliably identify simulated bivariate contemporaneous relationships under different contexts. So by simulating data, I sort of know what the true contemporaneous relationships between variables are because I simulated it, and therefore I can sort of assess how well different algorithms might perform on identifying those. And the reason I started with contemporaneous relationships first is, again, because it's a relatively new area of research. I guess I wanted to start just really, really simple from the first steps. And also there's a lot of research to suggest that, yeah, it is better to start with these simpler contemporaneous relationships before we go and explore sort of more complex bidirectional and temporal relationships. So the different algorithms I used was IRMAX, which is a time series regression model, Baruda, which is a machine learning algorithm that uses feature selection and random forests. And IRMAX and Baruda are both bivariate in the sense that they sort of look at the relationship between a variable and the outcome. I also looked at GIME and INSEM, which is individual structural equation modeling. And these two are multivariate network models that look at the relationship between variables in a network. And the difference between GIME and INSEM is that GIME accounts for group level effects first before identifying individual level effects, whilst INSEM primarily focuses on individual level effects without sort of looking at those group level patterns. I also looked at a bit of a hybrid model between IRMAX and Baruda, and I called that time series Baruda. And although not really an algorithm, I also included raw correlations into sort of the analysis, because I guess that's the most simple way of looking at a contemporaneous relationship between a variable and an outcome. So I chose these sort of algorithms as there's a bit of research suggests that they could be useful in sort of the goal that I'm looking for, which is to identify variables or processes that are associated with an outcome of well-being. All right. And in terms of the hypothesis, I hypothesized that IRMAX would perform the best, given that it's sort of designed for linear data, which is sort of the data I simulated so far in the simulation study. I also hypothesized Baruda will perform slightly worse than IRMAX because it's not designed solely for linear. It also includes can also include nonlinear data. And then GIME and INSEM would be the least effective given their complexity and the simplicity of the task that I'm asking it to do, because GIME and INSEM tends to estimate relationships between variables while controlling for the influence of all others. And I think when looking for these simple bivariate contemporaneous relationships, it might sort of struggle a bit more, these two methods. In terms of the methodology of the simulation study, so the first step was simulating data based on real-world data or real-world psychological daily diary data. And we did that to ensure, well, I did that because I wanted to make sure that the simulated data was actually sort of realistic. It might be something that we actually see in the real world. And the real data sort of had 5 independent variables and 1 outcome variable. I then compared the simulated data to the real data to ensure that the sort of within-person relationships that were in the real data were sort of accurately reflected in the simulated data. I then simulated various different conditions because I wanted to see how these methods would perform under sort of different contexts. And this is a little bit of a flowchart to sort of hopefully make it a bit easier to understand those first 3 steps. So like I said, I started with the real data, which had 102 individuals and 70 time points. I then simulated 100 data sets that were based on this real data, again with 102 individuals and 70 time points. And this is where I compared those within-person relationships between the simulated data to the real data by looking at density plots and ECDF plots of things like within-person correlation, within-person autocorrelations. I also ran a within-person meta-analysis on the simulated data and the real data to compare how similar they were, and all those results were very, very similar or near identical. So I could sort of safely assume that those within-person relationships that were in the real data were accurately captured in the simulation data. Like I said, from there in step 3, I then simulated different conditions or contexts, and I did 100 data sets for each of those. So things I manipulated were things like the number of time points in the data. I also added a linear trend to the outcome variable and varied the size of that. I changed the effect or the association between all the variables in the outcome to differing sizes. And I also added an autocorrelation to the dependent variable and manipulated the size of that autocorrelation as well. Again, just to see how well these different algorithms might sort of perform under different conditions. So then for step 4, because of the different format of result outputs for different algorithms, I classified variables as reliable based on simulated contemporaneous relationships first, and I'll go into that in a bit more detail in a second. I then ran all the algorithms or models on the simulations, classified variables that were identified by each algorithm as reliable, and then compared performance metrics by comparing those classified as reliable based on the simulated contemporaneous relationship and those identified by the algorithm. Sorry, mouth is very dry. So in terms of going to a bit more detail around classification, so like I mentioned before, to assess the performance, we classified variables as if they were reliable correlates of the outcome, or reliable variables. I'm going to use that term from now on, based on their simulated contemporaneous relationship with the outcome. We then compared those to those variables that were identified as reliable by each of the algorithms. So first, what we did was we classified what we consider true reliable variables using the simulated contemporaneous relationships. And I used three predefined thresholds that were based on Funder and Ose's effect sizes. So for the small effect size threshold, that meant that any variable with a simulated contemporaneous relationship with the outcome that was above 0.1 in size, that was classified as a reliable variable. So in the medium effect threshold, similarly, any variable with a simulated contemporaneous relationship above the size of 0.2 was considered a reliable variable, and then same for large, so anything above a 0.3 we considered a reliable variable. So like I said, then we compared these sort of true reliable variables, true in the sense that we know what, or I know what the simulated size of the relationship was. We compared these true reliable variables to the variables that were identified as reliable by each algorithm. So each algorithm was a bit different. So for IRMAX, any variable that was significant based on the t-statistic score, it was classified as a reliable variable. For Baruda, any variable that Baruda confirmed as significant was classified as a reliable variable. For Gimme, any path that was present in between a variable and the outcome in the result output was classified as a reliable variable. And then for InSem, similarly to Gimme, any sort of present beta between a variable and the outcome was classified as a reliable variable. So I do sort of want to acknowledge that I guess the use of effect size, or my use of effect size as a shorthand for identifying reliable variables, does have its limitations. In particular, I guess when it comes to distinguishing between statistical significance and sort of practical and clinical importance. So therefore, sort of the comparisons more so focus on the alignment between each algorithm's identifications and the size of the simulated relationship. So essentially, I'm assessing each algorithm's ability to correctly identify variables with varying levels of influence on the outcome, which is determined by the strength of their simulated relationship. So now that we've classified those variables, like I said, I could sort of compare the true reliable variables with those identified by each algorithm using these performance metrics. So I use sensitivity, which is the proportion of true reliable variables, which was based on the simulated contemporaneous relationship that were correctly identified by each algorithm. There was also specificity, which is the proportion of true non-reliable variables based on that simulated relationship that were correctly identified as non-reliable by each algorithm. Precision, which was the proportion of identified reliable variables by each algorithm that were true reliable variables based on the simulated contemporaneous relationship. And then the F1 score, which is a balance measure that combines precision and sensitivity into a single metric. So in terms of the results, for the sake of time, or because of time, I'm only going to go over sort of the main findings that I found. And I guess if there is time at the end, I can briefly touch on some of the other findings as well. So in terms of performance, we first compared each of the algorithms on that initial 100 data sets that were just based on the real world data without any sort of manipulation just yet. But again, because we simulated it, we know, or I knew what the true contemporaneous relationship was. Excuse me, my mouth's very dry today. And in terms of these results, what I found was that raw correlation IRMAX were the sort of best performers overall across the metrics, sort of as hypothesized, and as hypothesized as well. Baruda performed slightly worse, but was still relatively good. And then Gimme and InSem performed notably worse than the other algorithms. And this was sort of consistent across the different effect thresholds. So the last threshold we can see here. The medium effect size threshold, similar findings where sort of raw correlation IRMAX were generally the best, Baruda second, and then Gimme and InSem performing notably a bit worse. What I did notice was, though, as the threshold got smaller, you might notice that the specificity score for raw correlations did drop quite notably. And these results were pretty consistent across the varying number of time points and varying number of variables in the sense of how many variables were entered into each algorithm. So based on these results, I sort of chose to focus more so on raw correlations, IRMAX, and Baruda for some of the other comparisons and simulation conditions because they sort of stood out across these results as sort of the best performers. So I then added autocorrelation to the outcome variable and varied the size to sort of see how well each algorithm performs when there are autocorrelations present. And what I found was that IRMAX remained relatively consistent in performance across small and large autocorrelation sizes. But what you might notice here is that Baruda and raw correlation specificity drops significantly or notably as that size of that autocorrelation goes from small to large. And again, this was consistent across those different effect size thresholds. So that for the medium effect size threshold, a similar finding, if you look at IRMAX, relatively stay sort of consistent, or there's a bit of drop of sensitivity when that autocorrelation became large. But again, looking at Baruda and raw correlation, some massive drops in specificity. And the same for the small effect size threshold, where there's massive drops in specificity as well. So what those findings suggested to me was that it is quite important to account for these sort of time series elements like autocorrelations when analyzing this sort of data, particularly in the context of identifying contemporaneous relationships. So IRMAX does that inherently in its method with the AR, the autoregressive component for it, whilst Baruda and obviously raw correlations don't do that. So based on these findings, like I said earlier, I also created a sort of hybrid model that tried to combine IRMAX and Baruda so that I could account for these time series elements before entering data into Baruda. And that's what led to time series Baruda. So what I did with time series Baruda was I first entered each individual's data into an ARIMA model, which removes these time series elements like trends and autocorrelations. I then extracted the residuals, which is the leftover variance after that previous step, and I entered these residuals into Baruda. And like I mentioned, I called this time series Baruda. And what I found was that when I accounted for these time series elements like autocorrelations and trends and these other things in the data before entering into Baruda, it sort of resolved or increased specificity and precision quite massively. But what I did notice was it came at the cost of a drop in sensitivity. So if we look at the medium effect size threshold, again, specificity, precision sort of do really, really well, but there's this drop in sensitivity when we compare time series Baruda to Baruda and also IRMAX. Similar finding with the small effect size threshold, very high specificity and precision, but sort of a much lower sensitivity. So I'm not completely sure why Baruda sensitivity drops so notably. One possible explanation is just how conservative Baruda is, as it uses a 0.01 p-value and bond for any corrections. But if anyone else has any possible ideas or theories on what might be happening there, I'd love to hear it as well. And yeah, so the next steps for my PhD will be, like I said, looking into that time series Baruda sensitivity and trying to figure out what might be going on there. Like I mentioned a bit earlier, the sort of simulated data that I used, or the data that I simulated in the current study at the moment is all linear. And realistically, in the real world data, there might be data that is nonlinear. So my next step is also wanting to simulate some nonlinear data to see how these different algorithms might perform as well in that context, particularly with Baruda, which, like I mentioned earlier, sort of can handle nonlinear data as well. And like I said, measure the algorithm performance with nonlinear data and see sort of how they perform. After that, I will start on my third study, which, like I mentioned, is a feasibility and acceptability study. So now that we know, yes, personalization is beneficial, and hopefully after I finish the simulation study, we know what tools will be very helpful. Then we need to figure out, okay, well, how can we implement that into a real world setting? So the plan is to collect some EMA data from youth at headspace centers around Sydney, and then analyze that data using either IRMax or time series Baruda, depending on how the findings with the nonlinear data go. And then getting sort of clinician and youth opinions on their thoughts on this sort of data-driven model of personalization and implementing that. And the ethics for that has already been submitted. So yeah, and then that's just a quick little timeline of my PhD. So these are all done. Simulation study is almost done. So I put a very light completed on it. And yes, the next step will be getting the feasibility study done. And yes, that's it. Thank you.
Well done, William. Thank you very much for that.
Thank you.
So can I defer to Teresa as chair to lead the next session?
Thank you so much, William. That was very impressive and it looks amazing. Let me say that first. And well presented, very well structured, and spoken about in a manner that we can all follow along with those technical details. Because it seems to me like you have the details of your research, you've got them covered. Like I have no concerns at all, but I do have a larger picture question. And maybe I just missed it in the document. But so from what I understood is in your meta-analyses, you were looking at personalization. You were not looking at data-driven personalization. In fact, only one of the studies had used data-driven personalization, and then there was another one that used something related. And so you have found out in your first study that individualization works. You have, and now your next studies are already based on the assumption that individualization that is data-driven works. Or I think I have a bit, I have a bit of a disconnect between individualization. Like I can only imagine how that looks without data-driven, and then translating it into the data-driven. Like there's a bit of a, it seems to me like there's a little bit of a step missing, at least in the document in its current form.
Yes, no, I think that's a well pointed out thing. I think sometimes I get so consumed in the PhD because we're so focused on it. I guess you miss these little points. So thank you for pointing that out. I think my thoughts around that is that yes, the meta-analysis showed us that personalization does have benefits. I think because it's a relatively new area of research in the sort of clinical psychology, like I mentioned, there was only 8 studies, which is quite a small number. So I think, although yes, it does show that personalization is beneficial, there is this huge variance and differences in how different people are personalizing. So I think we can't, like you're right, we can't say that data-driven personalization definitely works, but there's also, I think, no research out there that we can look at to sort of determine if it will work or not. And so I guess my gut, and I guess the gut of a lot of my supervisors are sort of saying that this could be a very useful approach. And I think hopefully my PhD will lay that groundwork so that we can try and implement that, which then hopefully in the future we can look at that efficacy with RCTs and pilot studies to determine if it actually is beneficial in this sort of more specific data-driven personalization approach. Hopefully that answers the question a little bit.
Yes, it does. Thank you very much. I think I would encourage you to just keep it in mind that you have to put that into words for for the assessors to follow along, like this jump, which I'm sure you will, and your supervisors will take care of that. And again, amazing work, right? This is a very, like a cherry on the top comment. And that's it from me for now, and I'll just open up for the panel first. So I think that's you, Jesse. Right?
Yep. First, I would like to say that, like, congratulations on your publication. I think it's really impressive to publish a study from your PhD, like just in the second year of your PhD. And I agree with Teresa. The document is well written and well presented. I got a couple of questions regarding your simulation study. The first one is about the design. So as you said, like you got five 5 predictors and what outcome, right?
Mhm.
And it didn't vary the number of predictors in the simulation.
Not in the simulation, but with the different algorithms, for example, like Veruda, you can enter a different number of predictor variables. So you can enter one outcome, and then, for example, 5 variables. So I did alter how many variables I put into the different algorithms. But because, I mean, if we're putting less, there's no need to simulate like a data set with less variables. I just entered less variables, if that makes sense.
Yeah, because I think it's the number of predicts quite important in this design, because like the metric you use to evaluate the model based on the reliable variable classification, right? So for example, the proportion of reliable variables. So I think it's important to value the number of predictors to see the proportion of non-reliable or reliable, the metrics. Yeah. The second question is about the metrics like you use to evaluate, because like you got 4, right? Sensitivity and like precision and F1 score, those metrics. And like from a clinical perspective, which metrics is more important in this content? Because the results quite different across different metric. If like you think like the F1 score, which is a more balanced metric, is important, then like the within person role correlation approach is like outperform like others. Like in many cases, particularly when you have a small effect size. So yeah, I just want to ask, like from clinical perspective, which metric is more important than the others?
Yeah, I was thinking about that actually. I don't have a definitive answer, which I think is why I used all of them, because then it gives me a broader sort of view in terms of how each algorithm is performing. But I think they are all quite important, because if an algorithm is good at picking up all the sort of true reliable variables, but then also picks up a lot of sort of non-reliable variables as reliable in terms of like a very low specificity, then it still probably isn't, in terms of like a clinical perspective, that useful. And the same could be said for the opposite as well. In terms of precision, I think that was just interest for me in terms of, I guess, how precise each algorithm is. But again, I think it has to be like a balance between all these metrics in order for us to actually, I think, say that there's clinical utility in using that algorithm. So yeah, so hopefully that answers it a little bit. But yeah, I can't say if there's one specific one I think that is the most important.
Yeah, so I think based on what you're saying, is like it seems to me like the F1 score probably is more important than the other, because like they sort of balance out different, sensitivity and precision.
Yeah, and I think as well, because with from my understanding with sensitivity and things like that, when the data is a bit imbalanced in terms of maybe there's a lot of reliable variables or there's not many at all, it can obviously impact that sensitivity. So I think you're right. Yeah, F1 score, I added that because it gives us that sort of extra little safety net, I think.
Do you have any explanation why the role correlation approach is doing pretty well compared to the others?
Initially, not really. I guess it's because it's looking, because I'm looking at the very simple contemporaneous relationships, which is, I guess, how A affects B at this time point. And I think if we think about it, raw correlations itself is basically just looking at that as well. But like I was mentioning with the autocorrelations and those other time series elements, when they get added in, we see that sort of raw correlations loses that sort of performance, and there are sort of issues there that things like RMAX sort of handle a lot better.
Yep. Okay. I got another one. Questions regarding your feasibility study you proposed as a study 3. So, how the simulation study gonna inform the study 3? Could you tell us a bit about the content of study 3?
Definitely, yeah. So the study 3, the plan is to try and, like I said, implement this sort of data-driven personalization into a real-world setting. But again, I'm not looking at sort of how well it does. I'm more looking at the acceptability and sort of feasibility of it. Like, how can we do that? So the plan is, like I said, to get EMA data from youth, which is the data. And then study 2 will help me inform me on what algorithms I should use based on the context of those youth data. So it could be, I mean, at the moment, it sounds like RMAX is probably the go-to, but like I said, because I want to simulate with nonlinear data, there might be a use of Boruto as well, or time series Boruto in that. From using those algorithms, my plan is to generate a bit of like a summary report that I can give to clinicians, and then what they do with that, I'm interested in knowing, but I'm not sort of as interested in knowing like the actual process. I'm more so interested in, yeah, their opinions. And like, yeah, so method 2 sort of gives me an idea on what algorithms I use for the feasibility study. Yeah.
Okay, thank you.
Thanks,
Thank
Jesse.
you, William and Jesse. And before I hand over to you, Herb, Keong, do you have any questions being a part of the
Yes,
panel here?
first of all, I just want to congratulate Will as well. Again, excellent work with completing study 1 and also the simulation study. Really nice to see that progression after your COC. Well done, and
Thanks.
very impressive as you got familiar with all the with R and the statistical process.
Yeah, that was a journey. So yeah, thank you, John.
Congratulations. Yeah. My main question is about the feasibility of your feasibility study.
Yeah,
I know, and can you convince me that this is feasible? You've got 1 year to do this. Tell me more. Convince me.
Yeah, I mean, maybe I'm just being too overly optimistic, but I think a year is plenty of time to do it. I've already got sort of provisional approval from Headspace centers because from sort of pre-existing professional contacts, and they're open for me to do it. So the plan is to only, because it's a feasibility study, the plan is to only get about 10 to maybe 20, if I can, youth sort of participants. And then from there, it's only going to be a 2-week EMA data collection period. And then they'll get a sort of pre-study sort of survey, get some demographic details and things like that. And then after the sort of 2-week period, they'll get a sort of post-study survey to get their opinions about the whole process. And similarly for their clinician as well. And it seems like from my meetings with Headspace, most of the clinicians there are sort of on board to sort of, they're keen and eager to sort of join the study as well. So I think the main hurdle might just be, in my opinion, participant recruitment. But the ethics has been submitted. So I think hopefully if that gets approved, I can start data collection, in 2 months or so. Sorry, not collection, recruitment in sort of 2 months or so, which I think gives me plenty of time to, at least in my eyes, to get that study.
That's great. 10 to 20 participants in a big organization. And I'm assuming when you say Headspace, different centers or one center?
Yeah, I have so far 3 centers that are
3 centers.
board.
Okay. Yeah. That convinces me. With recruitment is probably the most difficult thing. I've got a small suggestion. One of the big barriers to personalization, it's not the clients. They probably think that's a great idea. It's the clinicians. As a clinician, I'll go, you know what? I already personalized. Don't tell me what to do here. You are giving the summary report to the clinicians and getting their opinions. I think that's a great idea because that's the biggest hurdle to I think rolling out this. I'm wondering also if you could, as a suggestion only, get them to give opinions about the process of doing all this, the ESM. And I don't know how much they'll be involved in collecting that data, but as a clinician, you'd imagine that you will, a researcher would not be involved in collecting that data. They would have to do it if they're a clinician, and whether they can be at some level involved so that they can give some feedback about that process.
Yeah, no, 100%. If I remember correctly, I think some of the questions around for the clinicians were around the actual data collection process as well, in terms of how that impacted their therapy potentially, even though it's like you said, sort of potentially collected outside of therapy, but just if there are any impacts for them as clinicians and their sort of thoughts and opinions on that process as well. Because like I said, it's if we're trying to implement this, that is going to be part of it as well. So, yeah.
Okay, well done, Will.
Thank you.
Thank you so much, Keong. And Herb, you've got your hand up.
Yeah, just two quick questions. The simulation that you did, it was quite reasonable. It was good, very strong, but it was on very unrealistic data. as you pointed out. And that's okay. So you've made that clear. But then when you go to real data that is likely to be much more complicated, I wonder why you would not use each of the different algorithms in case, like GIME, for example, is going to be able to capture some more detailed sort of material.
Yeah. Yeah, I think that's a very good question. I mean, I considered that as well. I thought, maybe they could be used potentially in combination as well. Like, for example, things like Broda Iremax could sort of winnow down a large number of variables and then entered into more complex ones like GIME and things like that. I guess my reasoning is, like I was saying before, because it's a relatively new area, I really wanted to start just very simple. And then also I was thinking more so around clinical utility as well, in terms of like, will clinicians be able to sort of understand or try and implement these things as well if it's overly complex? So I thought, let's start simple and let's focus on this simple stuff first, and then potentially as the research grows, sort of getting into more complexities.
A second question following from Keong's about the feasibility. Our clinicians will have to collect this data, if you're going to actually use it, but who's going to analyze the data?
So for the feasibility study at the moment, it'll be me analyzing it.
No, I understand that, but if clinicians were actually to use it
using
in
it, yeah.
practice.
Yeah, so I mean, Joseph might want to jump in here, but we have, not we, but there is a sort of, would you call it app, Joseph, called MindGrapher that has these, some of these algorithms inbuilt into it, so that that app will actually analyze this data and spit out sort of like some tables and reports and things like that.
Okay.
Yeah.
Okay. So the clinicians aren't going to actually have to be.
No, yeah, they wouldn't have to do.
Okay, good. That's an important aspect.
Yeah, definitely. Yeah.
Okay, thanks.
Thanks. Yeah, I wouldn't want to be teaching clinicians how to use R and things like that.
Yeah, thank you, John Marshall. You've got your hand up.
Yeah, if there's time, I just wanted to ask a very general question, William.
Yeah, one more, last one.
Okay, I'll make it fast. It's what you're interested in is individualized or specialized care for the individual client, what works for this client. But doesn't it also matter a lot what the clinical concern is? Like one thing might work for me for depression, but the next person comes in with some other clinical concern, and that complicates everything, doesn't it? Like in your meta-analysis, were all the studies on depression, or are they 8 different clinical concerns? Does it generalize?
There were a broad range of different clinical concerns in terms of the meta-analysis. And in terms of, I think, that's a very good point in terms of those different presentations. I guess with this sort of approach that I have confidence in, that I'm researching, is that we're looking at that relationship between the different processes and outcomes. So that outcome could be changed. For example, for one client could be depression is that outcome. For someone else could be anxiety. But again, if we can find those sort of psychological constructs or processes that are associated with that specific outcome for that specific individual, then we might be able to target sort of that process in the intervention.
Okay, thanks.
Thank you.
Thank you so much, and I'm sure William is happy to take questions after we close this meeting for the public. And so I say thank you to everybody, and thank you for your interest. Thank you so much, William, for your great presentation. And I would like to ask the panel to stay on, and for everybody else to leave this meeting, and also for the panel to remember that the chat should not be used. Thank you.
All right. Thanks, everyone. I leave as well, right?
You leave as well, and we will call you back in when we're done. Thank you, William.
Okay. Thanks.